Okay, so BUT and BST are right angles. We know that because they gave it to us in the pictures. That is the given. Okay, so we have one angle. So what do we need to show triangles are congruent? Like what would be a way to show these two triangles are the same? Okay, like angle, angle, side, side, angle, side, something like that. So we need other stuff besides one angle. So what else in this picture, between these two triangles, what else has to be the same? Huh?
They have a side.
Side VT, they share a side. So I don't think you guys have seen this before in proof form, but what you say is VT is congruent to itself. And that's called the reflexive property. So now we have a side and an angle. Is that enough? No. Can anybody think of the other thing that we know has to be the same? Has to do with the circle, because they didn't draw the circle for nothing.
Is it TU and TS are the same?
Why do TU and TS have to be the same? Because why? Yes. Radii, that's plural. The plural of radius is radii. Radii in the same circle have to be congruent. And that's the reason. Okay, now how do I know these triangles are congruent? This goes back to the worksheet from Wednesday. Angle side side's the bad word. Did you guys forget the extra one? Right, these are right triangles, so that's kind of your first clue. If it's a right triangle, what's likely to be the case is hypotenuse. Like, which side is the hypotenuse?
It's the long side.
The middle side down here is the long side, yeah. That's the hypotenuse. Of course, this would be one of the legs. So triangle, let's say VST and BUT are congruent. And the reason is hypotenuse leg. Okay, now, did you guys write that down? Why can we now say that VS and VU are the same?
Because we know they're congruent.
Because the triangles are congruent, the matching parts have to be congruent. Does anybody remember what we called that? That came up last week.
CN, CP.
Close. Corresponding parts of congruent triangles are congruent. CPCT. Corresponding parts of congruent triangles. So I need to say VS is congruent to VU. Corresponding parts of congruent triangles. Yeah, it's a proof. It's tough. All right, the rest of these aren't that bad. Okay, 39. Okay, do you guys remember UV in the picture on 38 through 43. Oh, I should have said 44 actually. I'm going to change that. Oh, I was looking at the wrong one. It does say 44. I was looking at algebra 1. Okay. Do you guys remember this was Thursday's assignment? If U and V are the midpoints, what's that thing going through the triangle called? Mid-segment. And what do we know about a mid-segment?
Half as long.
UV is half as long as RT, and it's parallel to RT. So if the lines are parallel, that means like certain angles. Do you guys see angle R where it says 44 degrees in the picture? That means like angle SUV would have to be 44 degrees because those lines are parallel. Those would be corresponding angles. Also, YWT would have to be 44 degrees because, or sorry, I said Y. VWT would have to be 44 because those lines are parallel as well. Anyway, mid segments are half the length of the side they're parallel to. Okay, 39. Find the measurement of angle UVW. Oh gosh, I feel like I'm gonna have to draw this. Maybe I can get away with not drawing it completely. So it looks something like this. Goes through the midpoints. They said this is 44 degrees, and we're looking for angle UVW. So that's this one right here. All right, well, I just said if this is 44 right here, this is 44. Can you guys see it? Because these lines are parallel. These are corresponding angles on parallel lines. So they're definitely 44. So if this one is 44, with that one, it's also 44. These lines are parallel. You guys remember what these angles are called?
Interior.
Alternate interior. It's kind of like this one and this one. Yeah. These, so 44, 44, 44, 44. In summation, what number are we on? 39. It's 44 degrees. All right, UV. This one's a little bit tricky. So, what do we know about the length of UV up here? This guy right there. Half of RT. How long is RT? How would we find the length from there to there? If we know that these are the locations of R and T on the graph, how do we find the distance from there to there? Distance formula. Okay, you guys remember this one? X minus x squared plus y minus y squared. Okay, so what are the x values? That would be -2 and 6. So -2 minus 6 squared. And then the y's would be 1 and 0. That would be 8 squared is 64. 1 squared is 1. Okay, square is 65. You don't really want the decimal version of that because it's a mess and you'd have to round it off. Now, that's the length from here to here is square root of 65. So how do we find UV?
Half the square root of 65.
half of that, or that, you could put a half in front of it, or you could put square root of 65 divided by 2.
That's disgusting.
The decimal version is uglier, so that's why we keep it like that. All right. On 43, it says the x-coordinate of S. How are we going to find the x-coordinate of S? Forgot the trick on this one. Let me think about it.
We know the distance of R and T, and half that is U and V.
Oh, I remember. Okay. Well, yeah, this one's kind of a trick. So, do you guys see U in the picture? Point U. What's the x-coordinate of U? 0. And because U is the midpoint between R and S, its x-coordinate is going to be halfway between the x-coordinates of R and S. Do you guys follow that? Probably not, maybe not. Maybe if I point at this picture, that would make more sense. So I didn't draw the axes here, but there was a y-axis right here. We know the x-coordinate right here is 0. The x-coordinate here is -2. So what's the x-coordinate going to be up here? Well, how far is it from -2 to 0? 2. So remember, to find the midpoint, you have to average like these two. So the distance from here to here is going to be the same as here to here. So if the x-coordinate moves up by 2 from here to here, it's going to move up by 2 from here to here. So 0 plus 2, the x-coordinate is going to be 2. So for 42, it says the coordinates of W. How would we find the coordinates for, it's not a hard trick like the one I just did. How would we find the coordinates for W?
It's in between.
Midpoint formula. Do you guys remember the midpoint formula? X plus X divided by 2, Y plus Y divided by 2. Okay, that gives you the X coordinate. You add the Y coordinates and divide by 2 to give you the Y coordinate. So it's the midpoint of R and T. So you're going to use R and T's X coordinates and Y coordinates. Average them both. For V, it says the coordinates of V. So 44 is pretty much the same thing, since now we know that S is 2 from number 43. They just want you to find the midpoint between 2, 4, and 6, 0. So 44 would be the same thing. Okay, did everybody get a worksheet? $18 little questions. This won't take too long. This worksheet is about isosceles triangles. It starts easy, and it gets medium, and then it ends hard. So, just to warn you. Okay, on number 1, if those two base angles are congruent, how long is x going to be? 7. When the two angles are congruent, that means the sides across from them, it's going to be the same. It's going to be an isosceles triangle. So number 1 is 7. Not a trick question. Number 3, we actually didn't talk about this, but it's easy enough you could guess it. So when you split an isosceles triangle with a line down the middle, the base gets split in half. It makes 2 equal triangles. So if that top part is 6, the bottom part is 6. Okay, number 5. So up top is the vertex angle is 40 degrees. How do we find one of the base angles down below? Okay, if this is 40 degrees up here, how many degrees does that leave for these two? 180. All 3 of them together make 180. 180 take away 40 is 140. But then that needs to be split between these two down here, which we know these two are the same. How the heck? Okay, anyways, 140 is split evenly between these two. 140 divided by 2. 70. You guys remember that trick? Number 7 is pretty similar. I didn't draw it very well, but it doesn't really matter. Okay, if these two sides are the same, which 2 angles have to be the same? These 2. Are you guys able to identify the base angles? You kind of imagine like this shooting across to this angle, that shoots across to that angle. So if these 2 sides are the same, those 2 angles are the same. So they said this one, I think 54, is that what they said? Yeah. This is 54. Darn it. Which makes this one 54. So how do I find x? 180 minus these 2. So these 2 add up to 108. 180 minus 108 is 72. Okay, on number 9, what do we know about the... Okay. So we got this is 65. So what's this angle right here have to be? 65. How do I find this angle? 180 minus these 2. These 2 make 130. 180 minus 130 is 50. That's not the answer. I didn't draw the whole thing. If this is 50, what's this? And then what else is marked? These 2 are marked. So if this is 50, what else is 50? No, bottom left. Actually, you're right. Sorry. You're right. I thought I was marking the wrong one. So this is 100. 180 minus 100 is 80. That was a lot of work. Not that many. Oh gosh, it's hard to draw all these. Got something like that. These 2 are the same. Got a little triangle down here. I think these 2 are supposed to be the same. Oops. these are all the same. Okay, and the one angle they give us is 148. We're looking for X 148. Okay, if this is, gosh, this is a mess. If this is 148, how do I find this guy right here?
You do 180 minus.
Right. This is supposed to be a straight line. So this is, they should make 180. 180 minus 148 is 32. Okay, we could mess around in this triangle a little bit, but it might be easier. If this is 32 and the whole thing is 90, 90 minus 32 is 58. This is 58. What else is 58? That one. Because this is a isosceles triangle. Base angles are 58. Right, together they make a straight line. 180 minus 58. 122. Kind of ramped up in difficulty, didn't it? On number 9. Oh my gosh. Okay. On 13, those two triangles are congruent. You guys know how I know that?
Angle, side angle.
Angle, side angle. So therefore, -1 plus, so if the triangles are congruent, then -1 plus x is the same as 8. Therefore, they are equal. And what is x equal? Okay. By the way, we're looking for x on all these, not necessarily just the angle. Most of these x has been the angle, so we hadn't had to worry about it. But all right. Something like that. Okay, this one we got 47. So if this is an isosceles, these two angles are the base angles. This would be 47. If this is 47, the vertical angle is 47. If this is 47, what else is 47? This is 47. So 180 minus these two will give you the third angle in the triangle. They're 94. 180 minus 94 is 86. Okay, normally we would be done there. However, if you look at the directions, yeah, it says x plus 94 equals the angle. So x plus 94 equals 86.
So x equals
No.
wow.
The angle is 86, therefore x must be -8. Uno más.
Oh, I was looking at 50 or 13. I was looking at 13. That was like 86 plus 94. There's nothing we did on about 13.
Okay, 15 is the x plus 94. We found that angle 2, was 86, so therefore 86 equals x plus 94. And then we do a little bit of algebra. Okay, one more drawing. See if I can do it. This goes way out here. This is a 90. This is a screwed that up pretty bad. Alright, that's close enough. Alright, what angle did they give us? 118 up here at the top. Okay, if that's 118, how do I find this guy right here? This one. Together they make a straight angle. So it's 180 minus 118. 62. Okay. 62 is one of the base angles for this isosceles triangle. So this would also be 62. Alright, we could find this angle and then do 180 minus that to get angle 2, or we could find this angle. Let's go with option A. These are both 62, this angle would be 180 minus 62, minus 62, minus 124. And that would be 56. And then this, if this is 56, this is straight line, 180 minus 56, which is 124. So 3 angles in a triangle add up to 180. Angles that make a straight line add up to 180. And the other trick we use is base angles in an isosceles triangle are congruent. Those are the 3 tricks we used over and over and over.
Do we have to find X?
Oh, is there an X thing on this one? Okay, angle 2 is 12x plus 4. So 12x plus 4 equals 124. Throw in a little bit of algebra just for fun. 12x is 120 divided by 12.